Hi, welcome to Shash. My name is Lisa Shashkova, I'm a software developer, and today I would like to present the third part of my series about design patterns in Python. As you remember, I hope, there are three groups of design patterns. They are creational, structural, and behavioral. We've already considered first two groups, creational patterns, which describe the way objects are created, structural design patterns, which describe composition of classes and objects. And today I would like to talk about the last group, behavioral design patterns, which describe communication between objects. This group is the biggest among all of them, but I hope it will be interesting for you to listen about it, because it's actually the most interesting part of all the design patterns, from my point of view, of course. This video I'm recording, experimental video, I'm recording it without my face, so please share in your comments, do you find it more comfortable for you when I record only my voice without my face? Let's give it a try at least. And again, I'm going to show a lot of examples in Python, because it's much easier to understand some concepts when you look at examples. Okay, and let's start. The first design pattern, chain of responsibility. It's design pattern which delegates commands to a chain of processing objects. That's actually a pretty popular design pattern, because it happens pretty often. For example, you have some form where user enters some data and you need to validate it. So you need to create validators for different fields in this form, and form may be changed, and handlers, there might be some additional handlers might appear, or a lot of other things might happen. So we need to work with it somehow, and this design pattern helps us to do so. Or we can consider a real life example, like tech support. So something doesn't work for user. What they do? First of all, they chat with some chatbot on your side. If it doesn't help, then they go to a real person, and only after that they will help to solve their problem. So there are different levels, like email, chatbot, and real person, and they handle it in a specific order. They work on different levels. Here is something similar. So we have some form. Here is described as we have some internet shop, like we have orders. So there are order ID, username, and price. And we have different form validator. All of them are inherited from handler, which need to implement handle method, which just checks. So there is handler for checking order ID or username or price. The interesting thing here is that there is also a method setNext. So each handler has a link to the next handler. So we have a linked list of handlers, and they store information about each other altogether. And when we're handling our form, we either report an error which happened, or call the next handler which we have, which is also pretty nice. How it works? Let's just see how it works. So what's going on here? We created our order handler, created all the necessary handlers, and put them in the linked list. Again, we don't have the list as data structure, it's just a sequence of colors. And we have our form, and we call client code here. Let's try to execute and see what's going on here. So in the first form, we've got an error. Form is incorrect. Form has invalid username. How it happened? Our client code called handle for the first handler. What happens here? Our first handler is here. It checked the order. It's not known. So it called to super and called handle for the same form. This form have come to the username handler. Again, the same handle was called. There were no problems. The problem appeared here. So there was invalid name and the error appeared. That's why we see it. For the second form, nothing is wrong. So everything was correct. And we just return form is correct message right here, which is actually pretty cool. And again, the coolest thing about it is that we can add as many handlers as we want, and even our form changes, we can add all the necessary handlers without changing the whole structure. There will be just additional implementations of these handlers. This is really cool. Well, now let's move to the second design button, and it's going to be a command. Command design button creates objects which encapsulate actions and parameters. So usually when you create object, you usually store some parameters there, some fields like some values, but command stores not only parameters but also actions which should be done with these parameters. It encapsulates, it hides it from users, and that's really cool because users don't care, can skip this non-necessary information for them and can do whatever they want. So here is our pretty simple command interface. There is a simple command. We need this parameter payload which we pass to it, and execute method which is just prints this payload to the output. There is a more complex command where we pass not only parameters A and B, but also this action receiver, something callable which will be called inside our execute method and will be executed with these parameters. The most important thing here, as you can see, that execute doesn't have any parameters. So client code can look like this. It just takes command and executes it, and that's it. The most interesting here is here on the stage where we create instances of command, where we create this receiver which does some activities. And on the client code there is nothing. We just call these things and they just do something. So you can see simple command executed. It just printed hi, exactly what we wanted. Complex command, well, it's more complex. It executes this code, so it's called complex command and does something and something else for receiver. And that's how it works. So the cool thing is that you can create instance of command and then pass it as a different parameter, store it in some other class, and once you call execute for it, it will execute all the necessary things which you needed from it. And you won't know what exact things are stored inside this command. That's why it's really cool. Okay, let's move to the third design partner. We have 10 design buttons. And now we have the third one. The third one is Iterator. Iterator for visiting elements of a collection without knowing anything. It's internal implementation. It's very popular design pattern. It's part of many programming languages, object-oriented programming languages, cool languages, for example, in Python. I've actually even recorded a video about what's the difference between iterators and generators in Python. Please look at it if you haven't seen it yet. It's really useful because it's a pretty popular question for Python interviews. And now we'll implement our own iterator again, as we did it, almost as we did it in this video about iterators and generators. So we implement iterator, which iterates over collection elements, and it has one parameters, so it can iterate elements in direct order or in reversed order. It's just a boolean flag here, which we passed into our constructor. And as you remember from my old video, we inherited from our iterator class, and we implemented next method, dunder next method, which returns the next element for your iterator. And here our flag changes the way how we select the first and the next element for our iterator. For if order is direct, the first position is 0, and we add +1 to our position. If order is reversed, the first position is -1, the last element, and we add -1 to our position, which is pretty logical, I would say. Now let's check how it works. Okay, yeah, so here is our collection. We implemented iterator. It's printed items in direct order and in reversed order. The coolest thing here is that we don't know it is list. It's just some collection where we can access elements by index, so it can be any other collection which supports it, our own implementation of list, or actually anything. Our iterator will work with any such collection. And we can, of course, implement some more complicated iterators orders, or more complicated, add some additional options here, which is also great. Cool, that was iterator, and now let's go to Mediator. Mediator is really useful in the big systems where you have a lot of different objects which need to communicate with each other, and usually when you need them to store information, to send information from one object to another, it might be, well, really difficult, because you will need to store some links from one object to another. There might be tons links from group of object to another group of object. That will be pretty difficult, and that's why Mediator design pattern was created. So it's some object in the middle which helps you to remove all these chaotic dependencies between objects. It restricts communication between the objects, and it forces all of them to communicate via this Mediator object. Something similar we've seen in the facade design pattern, when we hide details of the implementation and we just show on the beautiful side of our of our program. It is something similar. So here is our interface of Mediator, like with method notify, with sender and event. And here is our Mediator, which stores information about components, sets links to Mediator objects for each component. And now when there is a method notify, and depending on event, it sends it to the exact component and some additional things. So how it works, we have some base component, we have two implementations, component 1, component 2, which do something about which want to notify each other, and Mediator, which implements these notifications. Let's run this code. So what happened here? Component 1, component 2, our Mediator called, and client triggers operation A. For our component 1, we triggered operation do A. We notified Mediator about it. It received our event A and sent this information to component 2. Well, now component 2, it does do C, which also notifies Mediator about event C, which does nothing. Well, it done it. And the similar client triggers D. Again, Mediator helps us to send this information but without components. The cool thing again is the same, is that components don't know actually anything about it. They know only about events, so we can add some additional components or remove some of them without rewriting the whole system. The system is still very easy to decompose, but we have this Mediator object. It's pretty dangerous. It can become a God object, some very, very large object which stores a lot of information about application. But, well, please try to avoid it when you implement Mediator object. Cool. That was Mediator, and now it's time for Memento. Memento design pattern provides an ability to restore an object to its previous state. In other words, it allows you to implement undo action in your application. How can you do it? First of all, you need some states, something which can be stored in your program. For example, stored as this information into a file like JSON or XML, or stored into database. So it's something that some state, so you can store your whole program state to this program state to this state, and then, which is also pretty important, you need to have an ability to restore your program state from this stored data, if it's possible in your case. So you can use this Memento design pattern to store it. So we have our class Memento, which allows us to get some saved state. There is this originator, this second part of our Memento design pattern, which also have methods save to Memento and restore from Memento, which is pretty logical. And you can introduce even an additional object, caretaker, which stores all these saved states. As you understand, there might be many states during your program. Usually you can click Ctrl-Z many times, and usually your program stores all this information for you. And let's just see how it works. So in our case, it's just a toy example. So our states are just strings with names, state 1, state 2, and so on. Let's see how it works. A lot of outputs. So we created originator. We created caretaker based on this originator. What's going on after that? We set state 1, we set state 2, we saved this state 2 inside our caretaker. Then state 2, and then we saved it again, and state 4, and we decided, oh no, we would like to restore our state. What's going on here? We called this method. We remember, we know that we want to restore the last one. So we call to our originator and we tell them we want to restore our state from Memento. And our Memento got the save store and returns it, in our case just prints it to the output, and tells us what's the current saved state. So what's going on here? Exactly, we set state 1, state 2, saved to Memento, state 3, saved it again, state 4, and we restored from it. So our state after restoring is 3, which is pretty logical, which it works similar to stack data structure. Like you add something to the end of your list, and remove also from the end. So it's last in, first out. Items which you added later will be removed earlier, which is also pretty useful and can be used to implement undo action in your application. Okay, let's move to the sixth design button, and it's observer. This is very popular button, and it's actually pretty intuitive, so I think you will be using it, or you're already using it pretty often. Observer allows you to publish some events and subscribe to these events. So again, you don't store the exact link to the objects you need to you want to notify about some events. There are two main interfaces in these design buttons. There is observable, so something which stores links to observers and notifies them when some event happened. And there is observer, which receives this notification. So observable stores links to all the observers or listeners, and observer or listener waits for notification, which is pretty simple. So we created observable, we created observer 1, observer 2. Then some event happened. I don't know, user clicked on button, and you need to notify all the observers, all the things which were waiting for it. You need to send your order or close the window or do a lot of things and refresh your page or do a lot of things. So you call this notify observers. Observable stores information about all the observers, iterates over them and sends them notification. And then each observer does something which was implemented inside its notify method. Let's see how it works. Yeah, so observer 1 received notification and observer 2 received notification as well. That is great. This is how it works. And again, the coolest thing here is that we can, if needed, we can create 10 additional observers to the same observable, and without changing code of observable, we can easily do it, and it will change architecture of our program without changing a lot of code. Oh, it won't change architecture, sorry. It will add a lot of additional functionality without changing a lot of source code, which is really great. Nice, it was observer, and now let's move to the seventh design button called state. State allows object to alter its behavior when its internal state changes. It describes a design button where you can represent state as a separate class. So usually when we work with object-oriented language, we are used to working with it like object usually represents some things, not states. Usually there are some fields which are states, but here is the whole class which is state. For example, I think which is easy to understand, you have some application which is translated into many languages, and once your user selected some language, you need to show every string in this selected language. So this state, like selected language, will affect every call to show string in your program. It's state which affects a lot of additional things in your program. So here is example also similar to it. We are writing name which is a string, and the way we write it depends on a context. We can write it uppercase, or we can write we can write it lowercase or we can write it uppercase. The interesting thing here is that we have a list of strings and we want it to write the following way. We write the first string lowercase, then 2 strings uppercase, then again lowercase, 2 strings uppercase, and so on and so forth. How are we going to implement it? We want to implement state and its method write name, and there will be 2 states in our case, and the coolest thing is that we have context which stores information about state, and state updates the context. So once we printed lowercase, we set the next uppercase. Uppercase will change contexts only after it prints the name two names. Only after that, you can see if the count is more than 1, only after that it will set lowercase to our state of the context. Let's see how it works now. Yeah, so that's exactly how it works. First of all, we created a state context and the initial value is lowercase. Lowercase printed January in lowercase and set state to the uppercase. Uppercase printed February in uppercase. Well, but after that it didn't update state. This if is false. It executed one more time. Now the count is, it printed March, but the count is now more than 1, and it updated state back to lowercase, and so on and so forth. And that's how we received this result, and that is great. That's how we can print. So we can see our list of months doesn't know anything about it, but depending on the contexts we print it the different way. That's how state design pattern works. Cool. The eighth design pattern is a strategy. Let's look into it. Strategy allows one of a family of algorithms to be selected on the fly at runtime. Sometimes you need it, you don't understand, you don't know which algorithms should work in one case or another, and you can't predict it until you get some data. For example, user input or some data from the database or something like that. And you can't say for sure which exact strategy should work in this case, and strategy design pattern will help you here. So we have interfaces for strategy, do some algorithm, and to implementation. Some strategy A, strategy B. Here we just selecting the way to sort our list. It might be a direct sorting again or reverse sorting. What can we do here? Again, we create context. So we selected some strategy and some implementation which calls the algorithm method of our strategy. But here we don't know which exact strategy is selected. Only our code, only here when we set strategy for our context, we select this strategy, and after that client code just calls some business logic, and we don't know anything. There might be some more complicated if-else structure here, and we can't always say for sure which exact algorithm is called now, but it gives us a lot of opportunities. You can change selected algorithm right on the fly without changing your code, and without it will make it more easier to use, I would say. That's how it works. Now let's move to the 9th algorithm, template method. It defines the skeleton for some algorithm as an abstract class, and allows subclasses to provide concrete behavior. Actually, it's similar to the previous button, because there was ability to override the whole algorithm, and here we override just some parts of it. So for example, we have some method. It has different stages like initialize, start operation, finish operation, and complete. And many parts of it are very similar, for example, initialize and complete, but start operation and finish operation may be different. So what are we going here? We are inheriting our classes from the original class, right? And do our exact implementations for operation. Get client code after that just calls template method, and it doesn't know anything about the exact algorithm which will be used here. We just define it here when we pass it as parameter. What's cool about it again that we can change this internal implementations, internal algorithms, and client code won't know anything about it. So here we set the first class and executed concrete class 1, and the second case it executed operations from concrete class 2, which is also really great, and that's really cool, which allows us to, add additional implementations for these operations, or remove them, or do whatever we want. It won't affect client code. The behavior will be different, but the code is the same. It's because we implemented the great architecture inside our application. Okay, and now we're moving to the last design button, but not the least important design button. It's called visitor. And visitor lets us separate algorithms from the objects on which they operate. For example, when you work with complicated structures and there is a set of objects, all of them are inherited from some interface, and they need to implement, for example, like this component, they need to accept some visitor. Our visitor can visit collections of different objects, not necessarily collections, it can visit objects, and it can each visitor can work with separate types of objects. So it's much easier to understand when you see an example. For example, we have a component which has two implementations, component A and component B, with method A and method B, which is great. And now we have a visitor. As a component A, an accept visit, it tells visitor that it visits component A, and component B tells visitor that hey visitor, you're visiting component B. And visitor, it has implementations for both methods. And what's going on here? After that, you can implement even several visitors. So you have several components and several visitors. And then when you visit some component, you know that's your instance of this component, instance of A, and you can call method A, it has implementation. Or if it's instance of B, you can call method B, and it has implementations. So instead of writing really complicated if-else statements with expressions like if object instance of A do something and its object instance of B do something else and this and that, our program is decomposed. Let's execute it and see how it works. So we created component A, component B, created visitor 1 and called our component. We just accepts visitor for each component inside our collection of components, right? So what's going on here? Our visitor called our component accepts its component. As we remember, the first component was component A, right? So it tells visitor, hey, I know you're visiting component A, do something with that. What visitor 1 says, component A, hey, I visited you, and call method A. Then we continue our iteration and it's component B again. Accept called for component B. It tells visitor, hey, where is component B? Yeah, hey visitor, you're visiting component B. I'm calling your method for visiting it. Visitor understands, oh hey, okay, it's component B, so let's do, oh, it's still visitor 1, but in this case, on the second iteration, we called this method, component B, and it calls method B of our element. And so on and so forth, so the second visitor visits these components. It might be, look a bit complicated, more complicated than expected, but again, the coolest thing here is that such system can be easily expanded. You can add additional components or additional visitors. Of course, it's much easier to add visitors, which does different activities for different components, and you won't change any code here. You just need to implement visitor, and create instance of it at called client code. And it will be a bit more complicated when you add components. So if you add some component, right, you understand. So in this case, you will have to update all your visitors, because here will the method visit concrete component C will appear. But the cool thing is that old visitors, if they work only with components A, B, they can just ignore all the additional components. So possibly you can skip old visitors, they will work anyway if your new components are not necessary for them. But if you need them, of course, you will need to implement all the visit concrete component blah 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 methods in your visitors. But again, it will be much simpler than one big method with really complicated if-else statements everywhere. So that's why in a big application, this architecture will be much simpler and much easier for understanding. Cool. That was the 10th design pattern, which I would like to present to you today. So today we discussed behavioral patterns among our design patterns, the third group of design patterns. That was a long series. I hope you had fun while you were watching them, and I hope this knowledge will help you to create really great architectures when you work on large applications. Of course, when you work on some small pet project, or your program consists just of several classes or several files, it's not necessary to use design patterns. But once you start to work on really complicated architectures or programs, you definitely understand the advantages of using design patterns, especially when you need to extend your systems step by step, when business, for example, changes requirements or some internal configurations are changed, when your program is easy to decompose, when your program is easy to maintain, to expand, to add some additional plugins, and well, even it's easy to change your system according to change requirements. That means that your system is stable, your system is mature, and that your system was designed properly. I hope my videos will help you to do it, to design big, large systems really great way. I'll be happy to answer your questions if you have any. And thank you for watching me today. Don't forget to share your opinion about videos without my face. Maybe my voice is enough. Thank you very much for joining me today. I hope you had a great time. Thank you. Bye.